into the architectural foundations of Java: abstract, interfaces, and packages. We will try to understand these concepts in simple way. Imagine you are designing a virtual zoo with various animals, each sharing some common characteristics while having their own unique features. Let's bring this to code with the power of abstraction. First up, abstract classes. These are like blueprints for our animals. Abstract classes can't be expressed by themselves, but serve as a basis for other classes to extend from. Imagine an animal class with some common attributes such as names and species, allowing other subclasses like lion and elephant to inherit these properties while adding their own unique characteristics. Next up, we have interfaces. These are like contracts that ensure other classes follow to certain rules. Imagine our zookeepers need to interact with animals. We can create an interact interface which each animal class will implement, allowing them to have methods like make sound and eat. Lastly, let's talk about packages. Picture the zoo being organized into different sections, such as a mammal section, a bird section, and so on. Similarly, Java uses packages to organize classes, avoiding naming clashes and creating a structured code environment. To help you understand these concepts better, let's switch to the code editor and see how these work. Look at these lines of code. In this example, we'll have animals with distinct characteristics and behaviors. We'll use abstract classes, interfaces, and packages to showcase how they work. Here we have an abstract class named animal. An abstract class serves as a blueprint for other classes. It can have both concrete methods and abstract methods that are meant to be overridden by its subclasses. In this case, we have an abstract method named showInfo, which will be implemented differently by each animal. Next, we have an interface named interact. Interfaces define a contract that classes must adhere to. They contain method declarations, but the actual implementation is left to the classes that implement the interface. Our interact interface has methods like make sound and eat, which are common actions for animals. Now, let's move on to the concrete animal classes, lion and parrot. These classes extend the abstract class animal and implement the interface interact. This combination allows us to create classes with both shared characteristics and specific behaviors. Finally, we have the zoo class where we'll put our example into action. In the main method, we create instances of both a lion and a parrot. By utilizing the methods defined in the abstract class and the interface, we can showcase their unique behaviors. Let's run this code now. As we run the code, you can see how each animal's characteristics and actions are represented. The show info, make sound and eat methods are all being used here. Thanks to the inheritance from the abstract class and the implementation of the interface. And that's the power of abstract classes, interfaces and packages. They provide us an organized way to structure our code, allowing us to create more reusable and adaptable components. These concepts are fundamental to object-oriented programming. And now, I hope you now have a clearer understanding of its significance. Thanks for joining me in this exploration of interfaces, abstract classes and packages. Please like, share, subscribe and don't forget to hit that bell icon for more exciting coding topics. Keep coding and keep crushing them, and I'll see you in the next episode of Code Crushers.